So I'll introduce myself. On stage now is me. I'm Mike Elsmore. So this title is NoSQL is a lie. I work for a giant corporation, so I have to include a legal disclaimer to say that I can talk about whatever I want. I'll apologize right now. You may want to set the timer. Thank you. Right. So I work for a big corporation, so I need a disclaimer. So I am Mike Elsmore. I'm developer advocate from IBM. If you want to pester me or spam me or abuse me, there is my email address. Feel free to do so. Right. So I work at IBM Cloud Data Services. Anyone heard of that thing? Oh crap! People have actually heard of it. Right. That's usually, so my part of the world is operationalizing databases, so I help build prototypes and things for people based on those listed databases over there and analytics platforms. Just as an FYI, the majority of this stuff is open source stuff. So if everybody says IBM only ever gives you DB2, they're lying. We actually have other things, including NoSQL. So, most of my day, like most of you in here, starts like this. I'm a really bad software developer. I just build stuff quickly. So it starts like this. Sometime around lunch, I'll end up doing this because I can't work out why nothing is working. And inevitably, I'll do this because I broke it all in the space of a day. It's never a good start. Now, I've also got to admit, I'm really tired. I've been on stage all day, so I'm running low on energy, and I'm being really, really hyperactive right now. I'm also not an expert in this. I've tinkered with, played with, and messed around with all this stuff, but it doesn't make me an expert in this field. So feel free to correct me. Only way I'll learn is if people tell me. So it's also important to note that this is mainly opinion, just so that you can't sue me later for being wrong. So first things first, a controversial title like NoSQL is a lie requires a rant to explain it. And this thing actually gets me really freaking angry. So, NoSQL. Who here has heard of that term? All right, the entire room has heard of this term. It's a complete lie because of the fact that it's SQL. If it's not SQL, it must be NoSQL. Does that seem right to you guys? Is that a valid opinion of what NoSQL is? Ooh, nobody's agreeing with that. Good choice. So, NoSQL was this horrible backronym of not SQL. Anything that can be SQL interpreted must be SQL, and otherwise it is no SQL. It's a horrible backronym invented later on. Doesn't actually mean a damn thing. So there is SQL on NoSQL. Who here has been playing with Cassandra or Couchbase or anything with a Sparkle interface? Right. Have you happened to have seen something called an SQL select statement that happens to run on a NoSQL instance? Yeah. That kind of defeats the whole NoSQL is not SQL, right? Because there's SQL there. And there's schemaless thing here. Who believes NoSQL data systems are schemaless? Nobody wants to admit that. Good, because as a developer, as a BI guy, as an analyst, the moment you put information into the database, you're implicitly stating a schema, because if you put it in, you need to know what you're getting out. You can call it whatever you want, but is it a prescribed set of how the information is formed? Oh, that's a schema, right? Thank you. So, there is no such thing as a NoSQL expert. And I think this is a completely valid statement, because there are so many different types of NoSQL system. Right, would anybody in this room say they're a NoSQL expert? Good choice. Otherwise, I'd be pointing at you and going, wrong, and pretty much telling you to do this. Mainly because you could be an expert in a specific technology. You could be an expert in Mongo, you can be an expert in CouchDB, Redis, Memcache, React. Naming more would be pointless. You can be an expert in a specific system, but they all behave and work and are built entirely differently, using different languages, using different fundamental structures of how they share information. If you're an expert in all of them, I think you must be the smartest person in this room, possibly in the entirety of Europe. Yeah. I have a big ego, and seriously, I don't think I'm that good. So, there's the end of my rant. I've got to cool down a bit, calm down, because, well, a little bit angry. Just out of curiosity, any of my ranty statements, do people agree with them? Nobody agrees with me. You all think that NoSQL is still NoSQL. All right, let's let's get some proof into here. So I need to drop a little science on this to explain the history of why NoSQL systems are the way they are, to justify that it is a complete and utter fallacy. Who here remembers Cap theorem or Bowker's law? Oh, yes, what? Yeah, okay.
You get it to 90-some% of your assumptions, and that's good enough for the advantages that you get.
Yes and no. Right, moving on. So, CAP theorem actually stands for consistency, availability, and partition tolerance. You know, makes up the name of it. It's quite self-explanatory. Consistency, what you put in is what you get out. You put in one, you get one out. Does that seem valid? Okay. Availability. Right, this is a database. If your database is not available, what's the point? And partition tolerance. I like to think of this as the database knows where the information is. That's actually a lie. What it stands for is network tolerance. When a part of the system drops off, the rest of the system is able to cope and able to pull information from an alternative location. It's the reason why most of these systems are built in triplicate. So this little diagram, there's a little red dot right in the middle. This little space should be white. I can't find a Venn diagram where it makes it white in the middle, and I'm not really good with Photoshop, so it'll stay dark. This piece can't exist. It's a pick two scenario. The moment you have distributed systems, you have the uncertainty principle. The moment you have a distributed system, you have to know where certain things are. You have to have certain set parameters to work with. If you leave everything to be completely wobbly, eeny, weeny, tiny, whiny things, it's never going to work. So why does it need to have these set parameters to begin with from the design history? So for the historic point of view, everything was consistent and available. Who here has been a developer for longer than 10 years? Right, so some of these things, my next statement is going to make you laugh and grimace in pain. So the original systems, you didn't have partition tolerance because you had one giant box. And when that box got full or got slow, you put more RAM into it, you put more disk into it, you put more CPU onto it, and you just went, bigger box. And when that got full, by then there was new hardware, so you just go, okay, that's a bigger box. And eventually you got to the point where I can't fit the box in the room anymore. It's called a mainframe now, and I'm paying a little bit too much. But things changed. We ended up going into distributed systems and databases with commodity hardware coming up and allowing us to produce cheap, reusable, and stateless units that are just widespread. So the moment you start putting things onto multiple machines, you have to remember where they are. So you have to be partition tolerant. So you can be partition tolerant and consistent. So you can be partition tolerant and know what information you're putting in is coming right back out as it is, or available. Because if you try and rely on consistency and availability, that means you'll have to introduce table locking, which means you then can't do things like large distributed geolocated systems. You can't have the databases located in different data centers to easily distribute the information. At this point, you've just got a giant honking great table lock. Okay, nobody can read my database, my website, everything stopped working. Defeats the point. So you have to be one or the other. So with those design decisions, you have to be AP or CP. So NoSQL was born into this world of distributed systems. There's also, just to be completely fair, this policy called NewSQL. Who's heard of that? Oh, okay. It's actually something from Google Spanner, which is essentially a transactional version of Google's BigQuery system and Bigtable. What it does is it applies atomic clocks to all the machines so it can keep state and consistency by having ridiculous amounts of hardware. This does mean instead of having really cheap machines, you end up with a machine so freaking expensive you've paid for the clock before you've paid for the disk. It kind of defeats the point of building a distributed system when you're paying that much money. However, some of the guys have quit Google and have started something called CouchDB. So you can look into a software implementation of this yourself and have a play with it. So I'd highly suggest looking at it because the white paper around it is really, really interesting. But when we come to NoSQL, we're going to talk about these things. We're going to talk about key value pairs, document, column, graph, just because I need to limit the scope, because there are way too many. Does anyone recognize any of those terms from the bottom? So object, tabular, tuple, RDF systems for their databases. If I tried to cover all this, we'd need about 5 hours, not 20 minutes. So let's get started. Oh, we're also going to skip multi-model because there's a slight problem in trying to describe why you need a specific tool when you end up saying, right, we can use this one tool for everything. Kind of defeats the point of my whole talk, sorry. So if you want to play a game and try and guessing the name of databases and stuff, there's a little game there that you can have a go at later. I thought my slide talk session was 30 minutes, not 20, so we'll be skipping the game. So moving on. Key value stores. Can anyone name any of these? Crowd participation here. Redis, good one. Anyone else? Pardon? Memcache. Yep, that's a great one. Yeah, there are lots. This actually carries on for about 5 lines underneath. There are just way too many key value stores for me to remember. Not all of them are open source. A lot of them are proprietary systems as well, but I wanted to be complete when listing them off. So it's like, I haven't even heard of that one before I looked it up. Grid gain. But these are all key value sets. So it just means that it works like a dictionary or a hash or an array in any other programming language. You put something in and it's associated. So you look at 1, you get the data for 1. You look at 2, you get the data for 2. It's kind of self-explanatory. Does that seem fair? So why the hell would you use this stuff? At the moment, a key value store is used for very simple, very fast lookups. So partials like Memcache for rendering stuff. Sessions for large distributed systems. Queues for when you really want to be lazy and RabbitMQ just doesn't seem like a good option at the time. But yeah, it's a really versatile thing, but it's designed for doing very simple things very quickly. You're not meant to throw complex stuff at it. Except for recently, they did introduce geospatial querying on there, which in my mind defeats the point of being key value for Redis. It's kind of confusing. But okay, next up, document stores. Who can name any of these? Nothing? Couchbase. Yeah, Couchbase is document store. Yeah, they're different. But, so, CouchDB, yes, but there is some severe constraints on it, which is why it's in the list, but I don't really count it. There's also Mongo, Rethink. Azure has its own. Amazon has its own. Once again, there's a massive list of these things. They all do essentially the same thing. You put a JSON blob in, and you get a JSON blob out of stuff, which means it's just a large blob. It's more queryable. You provide more information, so it builds a better index off the metadata you're providing. So in the case of like Couchbase, they introduced their SQL library on top of that so that you can do more SQL-like simple queries. CQL for Cassandra, except Cassandra is something else. Then there's Lucene versions on top of CouchDB, which do these more complex queries. So it's like a key value store, but complex, which also means it's by nature slower. So why the hell would you use these? Primarily, your operational data store. If you're running business analytics inside of a document database, you're doing something really wrong because it's not designed for that. It's designed for being operational. It's designed for doing quick transactional pieces of right information for you, or just really good lookups on complicated data sets. Next up, Columnstore. Who can name any of these? Come on, people, be interactive with me. Shout. No one? Nothing? Pardon? Oh, technically, yeah. So yeah, there's the game, and here's the popular ones. It turns out there is actually a website for ranking the most popular NoSQL databases. So this isn't my research, this is me stealing somebody else's. So there's Cassandra and HBase being the 2 primary ones which are really famous, and then there's obviously Bigtable, Hypetable, and Accumulo, which I've only just started playing with. These things are the same as document stores in the way that they interact. Most of them have a JSON endpoint for grabbing and storing information, but underneath they store it entirely differently. Instead of storing it as metadata and objects, it stores it more like an Excel spreadsheet, where it'll just have blank sections and allow it to expand dynamically depending on how much information you have in there. Which means it's really, really, really good at storing dynamically sourced information with vector timestamps. Cassandra is amazing for... I'm looking at somebody with a phone in the front row. So it's we've got they're really good with vector timestamps because they're able to directly communicate with each other on their replication layers and just go, okay, new information. We can stack it in the correct order for quick lookups and keeping things in a relatively sane order. So why would you use them? Well, Netflix uses it to power one of the biggest services on the planet. It's just massively scalable, really quick to look up at. There are also, most of these, so HBase and Cassandra have really good replication protocols. Their gossip channels are just resilient beyond hell, to the point where people hate operating on them because they can't stop gossip from working when they need it to. It will still replicate and communicate across a cluster when half the machines are dead. It's fantastic. So it's once again an operational data store, but with a slightly different use case. Right, my personal favorite one, graph data stores. Who wants to name any of these things? Neo4j, yeah? And others? I can't hear that far, you're going to have to shout. GraphDB? Yeah. So yeah, we've got Neo4j, Titan, Giraffe, which is the one that Facebook released and then immediately abandoned after releasing it into the open source. I don't know why big companies do that, abandon it on release. It's like, here world, have some great code, your problem. So yeah, we've got a lot of them. Graph databases are just really awesome things. Who remembers their graph theory? Yeah, okay, so I'll have to explain it a bit. Right, it's more like a relational system, so it's the interconnectivity between data points. So a document will be a node, and an edge will be the piece of information that connects them. So third normal form connecting tables. What that means is these things get ridiculously powerful the more edges you add into them, so you then get interconnected information. You then get to build things like recommendation engines, fraud detection motions, social networks. So LinkedIn has one of the most powerful graph systems on the planet, and they won't open source it, and I hate them for it. But it's amazing. You can do really complex things. You can offload stupidly complex SQL server queries, which would normally kill Postgres, onto these things and just go, hi, have it. We'll give a result back later. So I'm tired. You guys must be tired. But soon there shall be beer and partying. But we need to summarize what we've just gone through. What we've learned. NoSQL is a lie. Who is going to agree with me? Please, one person agree with me. One person agrees with me. My job is done. Right. Do you understand why NoSQL grew in the way it did? Why it couldn't be consistent and available and be like MySQL and Postgres did back in the day? Nobody agrees with me on this. You all think I'm lying. Or you just don't care anymore. Either way. Right, who agrees that you should be picking the right database for a job? So if you're going to have a really simple thing, you should be picking Redis, Memcache, something really fast on the lightning. Something more complex, then you'd go for MySQL or an operational store like Cassandra, Couchbase, CouchDB. Or if you just want to go completely nuts, you're throwing a graph system in there and go, build things! There are some reasons to use different databases. Does anybody agree with the use cases I put forward and why you would use those systems? Okay, so completely valid. Right. So do you still think NoSQL is a lie? You still think that one term describes everything? Really? Just to troll me? So, pick the right tool for the right job, people. Otherwise, when you try to do the job, something weird will happen. Or you will just go nowhere. Your system will not even work as a distributed computing system. However, if you do it right, you never know, it'll just be really simple and you'll be quite happy with it. So, I'm Mike Elsmore. There's my talk and some slides and some information if you want to get it later. And, yeah, just running the slides so you can get the rest of the GIF. Mic drop. Thank you, everybody.